the system, which was the first thing we talked about when we started chapter 3. So in order to graph this system, Sadie, what do you have to do with the equations? Right. So y equals mx plus b. So our first equation looks like what, Sadie?
Y equals 4/3 x minus b.
Good. So taking the 4x over to the other side by subtracting it, dividing by the -3, 4/3 x minus 4. So that's equation 1. And then the second equation doing the same thing, taking the 2x over, and then Sadie, what did you get for that equation?
Y equals -2/3 x plus 6.
Right. So 2 equations that we're graphing, getting them in y equals 4. And then when you graph them, starting with the y-intercept, moving with the slope, and Jack, where does it look like the lines cross?
5, 2.5.
Okay, so he said 5 and 2.5. So there's a couple of ways that you can find the actual answer, because right now they're kind of crossing in the middle of a box and not in the corner because they don't cross at 2 exact points. So one way you can find the exact answer would be to graph both of these in your calculator and use the intersect option. So graph both of them, make sure you're finding the exact answer using the calculator. The other way would be to continue to solve it algebraically, and I asked you to use the calculator and matrices. So looking at this equation, Nick, how would we set up a matrix equation for these systems?
You will do 4 negative, the first box would be 2 by 4, would be 4 negative 7, 2, 3.
And that is called our coefficient matrix that represents matrix A. And then our second box,
X and Y.
right, that's our variable matrix, that's called matrix X. And then the third matrix, Nick, is
12 and 18.
12 and 18. And that's matrix B. So these are the same equations, same numbers that we just graphed. We're now setting it up as a matrix. In order to solve a matrix equation, so in order to get the x and y by itself, that's our matrix X, we need to take the inverse of A and multiply it by matrix B. And the calculator can do all of that for you, and unfortunately my computer shut down, so my calculator isn't up here. So you're plugging that into your calculator. You don't actually have to individually calculate the matrix, inverse matrix. Let's see if I can pull this up. So you're getting the matrix into your calculator, those same numbers that Nick just told me. Nick, what were those numbers that you told me again for matrix A?
4 negative 3, 2, 3.
And 2, 3. All right, and then matrix B.
12, 18.
Thank you, Nick. Okay, so when you put this in your calculator, I have matrix A, I'm taking the inverse of it. You don't actually physically have to show what matrix A's inverse is. So you can just plug it in your calculator as the inverse of matrix A. And then I'm multiplying that with the inverse of matrix B. So when we're solving matrix equations, if I'm finding the variable matrix, which is X, we're taking the inverse of A times B. Because that's how I take matrix A to the other side by using its inverse. And then when you hit enter, the calculator gives you the exact value. And the exact value as an ordered pair, because this is where the graph is crossing, at an ordered pair would be 5, and then it has 2.6 repeating. So you can either write it as 2.6 repeating with a little hat on top of it, or it's 8/3. But make sure you're finding the exact answer with your calculator. So the graph, sometimes it crosses, you gotta give a little estimate as to where it looks like it's crossing, and then use the calculator multiple ways. But you can just plug them into the graph, or you can create a matrix equation. Any questions with the matrix equations? So the second step on here wanted us to use the same equation, but use substitution. So we have the same set of equations, now we're trying to get substitution. You should get the same answer, because I've already solved it with the calculator and I've solved it graphically. So we should be able to get the same answer. Which variable do you want to use substitution with? Josh, what do you think?
Do with the 2x.
So you did this bottom one? Okay, and what'd you get by itself?
X equals -3x, y equals
You said +9. So Nick chose to solve the second, Josh chose to solve the second equation for variable x. You can use any of these 4 variables. All 4 of them are going to produce a fraction in some way. So it's kind of up to you which variable you want to choose, but you're going to get a fraction in the equation. You could have used one of the equations above because they were in y equals form as well if you wanted to do that. So kind of your choice. And then substitution says you take this equation, you go into the other, and you replace x because he solved for x. So instead of x, we have -3/2 y plus 9, and then minus the 3y that was originally in the equation equal to 12. Again, if you didn't solve it exactly this way, that's okay. You may have set a different variable equal, isolated a different variable. So Josh, when you take 4 times -3/2, you end up getting -6. So even though there's a fraction in there, it actually works out pretty nice because the fraction eliminates. And then we have 4 with 9, which is 36. And combining the y's together, taking the 36 to the other side, Josh, you get -9y equals. And when we divide by 9, you end up getting, how about -9? Say it again. 8/3, yeah. So you still get that 8/3, which we found with the calculator. We also had 8/3, or 2.6 repeating. And then after you have y, you go back in to get the other variable. So -3/2 times 8/3, and then plus 9. Does anybody know how to multiply fractions without a calculator? With your wonderful mental abilities?
Just multiply across.
Yeah, you can multiply across, so top, top, bottom, bottom. What else could you do with those fractions? Ava? Yeah, so we can cross cancel, cross reduce. So cross canceling, the 3's cancel because diagonally they're reducing. You have multiplication versus division. And then the 2 and the 8 cancel and give us a 4. So when you have fractions, you can cross reduce or you can multiply across. So you can reduce diagonally or just multiply top, top, bottom, bottom. So we're left with a -4 plus 9, which is equal to 5. Which is the same answer we got above. We estimated it graphically, and then we found that solution with the equations and the matrices. The last one wants us to use the system of final time and elimination. Nina, how does elimination work?
You Well, you have to like make one of them like negative, so like two of the variables or like two of the things, they cancel each other out.
Yeah, they're supposed to cancel each other out. You know what's nice about this problem?
4 and 2.
So 4 and 2 are pretty easy to cancel out. What else is nice about the problem? Leah? The y's would already cancel out because we have exactly what she was saying, the -3 and the +3. So I have the same number in front. One's negative, one is positive. So the y's can cancel each out as well. When you add the like terms, adding vertically, we have a 6x equals 30. So adding the x's, the y's cancel, and then x would be equal to 5. Leah, does it matter which equation you plug 5 in to get y? No, it doesn't. Pick the one you like the best. So we need to find y. You can plug it into either of those equations. If I plug it into the first one, so I have 20 that I'm taking to the other side, which gives me -8. And when I divide by 3, again, I get 8/3. So now we've solved 4 different ways. One equation, 4 different ways. Graphically, substitution, elimination, and setting up an equation with matrices. Questions? Are there questions you have on the homework? Looked pretty good as I was walking around. So the questions I have. So the review worksheet that I have for you, I will momentarily post the answers in Google Classroom so you can check those solutions. Tomorrow's test is 50 points. It's on all of Chapter 3, which we did a really good review of most of Chapter 3, right in that one problem. The only thing we didn't really talk about was kind of reviewing the multiplying matrices and the adding matrices, subtracting matrices. And there are some problems on this review worksheet going over those. So you have 20 minutes exactly to work on this. Grab a partner. Again, answers are going to be posted to Google Classroom in a few minutes. I'll post them. Please check your answers. Check your work. And if you have questions, please ask. But grab a partner, work with somebody on this.